These robots, they are, I mean, you've seen the video, they are like about the size of a dice, like about 2 centimeters cube. And they have little wheels. And then they have 4 sensors around their body that allow them to just avoid obstacles. So if they run into an obstacle, they will detect the obstacle and then they just move away from it. And the second thing they have on top of the robot, there's like 2 antennae. So these 2 antennae are actually 2 light sensors. If there's more light falling onto the right sensor, they will turn right. And if more light falling on the left sensor, they will turn left. So it's exactly the same mechanism as ants. They just lay this trail behind them as they navigate into the network. So mainly these robots here, their only task is to find the shortest way between their starting point and whatever target you're looking for into the network. So what is the fastest way to go from point A to point B? By themselves, this robot, they would just move around and they would get lost. Then they might reach point B from point A, but just by chance. But by working together and allowing them to communicate through this like light trail that you see in the videos, the robots will prefer to go where other robots have been before. The whole is bigger than the sum of the parts. So you take all the parts together and they do their own little behavior in their own little corner. But then when they start interacting with each other, it creates something bigger than them. You can imagine, in terms of application, you can imagine having these robots carrying material between different parts of a factory, of a plant. And you need to make sure you optimize the path they take, so the material goes faster from point A to point B. So by using this sort of self-organization, they can actually find this path, even if the factory is a complex network of buildings and machines and things happening everywhere.